In the morning, I show you about our industry, our struggling problem that we have with logistics for soybean in Brazil. And just after the discussion with the DDM, Cortiva, AST, and the buyer, we had a lot of discussion about the importance of breeding programs, seeding qualities, to gain the high capacity of soybean production. I want to put a little bit more petrol on the fire and show you more information that can maybe be important for this also. So just showing a few more numbers before start of this importance of different parts of improving of the soybean production system in Brazil. This is our agricultural area in Brazil. So it's 282 million hectares. There is equivalent more or less of 1/3 of the country. And 77 million is used to grain. So considering that 47 million hectares for soybean as a first crop in the summer period, so we have around 30 million hectares that's used for several other crops, not just grain, but for fruits, vegetables, all of stuffs. A huge area that we have in Brazil is for sure, like we saw in the morning, is based on pastures. So we see that we have around 165 million hectares of pastures in Brazil. So how can we increase the soybean area without going, like I show you in the morning, to the Amazon side and really going to other side of the country? So EMBRAPA looks that we can make a conversion of around 30 million hectares of degraded pastures for the next 20 years that can be used for grain production. It means that this area is not really producing any more grasses, the quality of the soil, the health of the soil is completely destroyed, but we can recover this and use to produce a good agricultural measure and agricultural practice over there. There is also another component that is increasing in Brazil, is what we call the agricultural livestock forest integration. So we can do in the same area forest, cattle, and agriculture. This is something that is increasing and we can see more and more in Brazil, but it's still just 17 million hectares of all our, let's say, 282 million hectares. About the crop successions or rotation, it means which crop is the most important after soybean in these 47 million hectares. So we can see that quite 70 million hectares is used with maize. So you see a huge difference. So quite, let's say, 1/3, a little bit less than 1/3 of this 47 million we use as a second crop corn. So all the others, we can be grass like brachiaria, that is the grass that we use for feed animals, but especially in the south, wheat, and some parts of the center of Brazil, we can also use as cotton as a second harvest. And some regions, we can even have a third harvest season in the same year, in the same area. But to be able exactly to produce 2, even 3 different crops in the same area in the same season, we need to be careful about the soil structure, soil health, and especially how we need to manage the fertilizer of these areas. One thing that is important that we saw in the morning that you have production of wheat, you have importing wheat also, but Brazil has production we can supply 40% of our wheat consumption in Brazil. We import a little bit more than 60%. And our barrier, that we are limited, is exactly because wheat is planted in cold regions. But what EMBRAPA is doing now is do the same thing that we did in the 70s for the soybean. We are tropicalizing the wheat. It means that we can actually start to grow wheat in warm regions. So this can completely change the wheat scenario, not just for us, but also here in South Africa. So I showed this slide in the morning about the productivity. So this was the last year, but this is important just to see what is the main purpose, or what is the main reasons that make Brazil so proud to say we're the biggest producer of soybean in the world. It's not one factor. It's not just the seed. It's not just how much area we have of soybean, but it's a mix of all these components. So especially plant breeding. I will not say that is the first, but one is the most important. So we have a good plant breeding program in not just EMBRAPA, but for sure all the companies, private companies, actually especially DDM, that is the biggest in Brazil, bring in early maturating varieties with higher adaptation and especially yield potential. In the last 20 years, Brazil, we moved a lot, thinking much more about yield potential, and for sure we lost in these last 20 years oil content and protein amount also. But this is one thing that we are taking care again about soybean structure. One thing that I explore a lot is this soil management, how we can make the conservation of the soil, and especially how we treat about fertility, because our structure of the soil, the Brazilian soil, is completely different of reality here in South Africa. But also, we developed several technology for pest control. So the pest in the correct concept about diseases, insects, and weeds, for sure we have problems. The seed production technology, and also the big change that we have from the 70s, 80s, 90s, up to have now about the machinery improvement that we have in Brazil. So this is the reality that we had in Brazil in the beginning. When the soybean arrived in Brazil, it was started the production in the 60s, it was mainly concentrated in cold areas, because all the germplasm that we have in Brazil came from the US. So US was planting soybean in cold regions, so we use exactly the same. After we start the tropicalization of soybean, we could handle in the first part of the 70s, really going a little bit deep in the center of Brazil. Then, in the 80s, we come maybe the big shift that we have in Brazil, the soil correction. This make a huge difference in Brazil that make us a huge importer of all agricultural products to the biggest exporter in the world. So what allow us to increase in all the center area after 2010. So when you consider the distribution about soybean production in Brazil, like I told you in the morning, 28% of all soybean production come from Mato Grosso states. Then we have Goiás, Paraná, Rio Grande do Sul. So this region and this region is equivalent around 80% of the whole soybean production in Brazil. So the huge importance, and like I showed in the morning, the good or the biggest industry to process, to crush, to oil production is also in these areas. But it's important you to have an idea about the latitude from South Africa and the latitude that we have in Brazil. So if you make a correspondence, so we say that we are here around 23 of latitude south, so South Africa correspond more or less to here, to north of Paraná, up to here, Buenos Aires, Argentina. So this is your difference of latitude. It means that when we consider this region, and it was the discussion about the maturity groups in this morning, what we saw is that what we have is a little bit different from we had in the past. In the beginning, when the soybean came to Brazil, it was common to have maturity groups from 6.8 to 9.4. After all these breeding programs, tropicalization of soybean, we have maturity groups from 4.5 in the extremely south of Brazil up to 8.2, and a few ones in the extremely north of Brazil that's already north hemisphere, it's 9.8. So before we started at 6 up to 10, so now it's 4 up to 9, and this region here, it's quite 10. But when you go to Argentina, for example, we can see that they have, in the same latitude that we're talking about here, from 3 to 4, 4, 5, this is in the south of South Africa. When you give a look also in the United States, the past, so before 2010, they planted from a 000 up to 9 of maturation group, and now they shift to 000 up to 8 of maturity group. So all countries that produce soybean are looking for early stage and maturation group to improve their productivity. Another big important difference is it was the shift from determinate soybean to undeterminate. So we can see the huge difference. So the indeterminate doesn't stop to grow after we have the flowering system. Another one, it was the lodging. So before we had cultivar that it was suitable to lodging, and now we have really moderate and resistant lodging plants that we can survive in really wind strong conditions. And for sure, the height of the plant, before we had plants that can reach up to 1.5 meters, and now we have plants that normally go up to 80, 90 centimeters. So this is really helps a lot to manage this on the field. But I'll say a little bit about EMBRAPA and then come back to the whole program. So what we look in Brazil, so I showed this map about maturity groups and all these difference of regions in Brazil. So what the breeding program that EMBRAPA normally are looking for, especially, so the main one is productivity and stability. So it was like Facundo told in the morning that GDM are also looking, so they always looking for stability of the soybean crop. But for sure, we're looking for maturity groups, plant architecture, lodging resistance. We have inside our breeding program some diseases that it's mandatory that we cannot leave any cultivar, EMBRAPA cultivar without some diseases resistance. But main of them, insect tolerance, seed quality, and we are also working in oil and protein content and quality, increasing the oleic acid amount and decreasing the olenic acid. So it's something that we are taking care. We already have some varieties in the United States with high oleic acid, and this is thinking about improvement of the chain of oil quality in soybean. So I show you the technologies that we already have that EMBRAPA is working. So I told you all these platforms, so the beginning of glyphosate tolerant, then with BT, here with the dicamba, and then we have the new one with dicamba, BT, and more too, so it means we have 3 cry proteins to insect resistance. This was the last one that we started together with Bayer to develop new cultivars in Brazil, as well as GDM and other companies that are making breeding programs. This is some numbers that we have from EMBRAPA in the last 15 years, for example. This is the diseases that is mandatory. We cannot deliver enough cultivars from EMBRAPA that is not at least resistant or moderate resistance to stem canker, frog eye leaf, bacterial pustules, wildfire, and Phytophthora. So this is mandatory. No EMBRAPA cultivar cannot go to the market without this resistance. So this is the numbers that we already have been working for in the last 15 years. And a big difference that it's really important is we have a huge difference of soil structure and soil quality and type in Brazil. It's just an overview, some pictures of how different can we have in the soil structure and the soil type of Brazil. And all the soil, even here, the splint soil, that it's quite a mix of soil and rock, how we can plant soybean in all of this. Even in regions that have a little more amount of sand, we can also use for sowing and have good yield production in soybean in Brazil. So this is our map, so our Brazilian soil map. You see how difference we have, so how we could arrive of this macro region, so not just 1, 2, 3, 4, 5, but 100, 101, 102, 103, and recommended cultivars for each macro region that I show you in the before map. It's using these informations with all other informations about weather and quality of the seeds and production. But I think this is one of the most important. So this is the pH of the soil in Brazil. Look at quite 90%, 95% of our soil is acid soil. It means we have really poor soils in Brazil. So we need to construct the fertility of our soil. Different from you that have neutral and alkaline soils, our soils is totally different. So for the reason that what I show you about our fertility is not really applied for you, but it's important that you have all this soil analysis to know exactly how you can get the most yield potential of the cultivars. And this is one of the most important discussions that was starting this morning with the group here. It's not just a question of they can bring the best seed generation technology, the last GDM improvement quality of seed that they can bring. If you don't have quality, fertility in your soil, it doesn't matter which kind of seed you bring to South Africa. So this is some most common disorders of nutrition in Brazil. You can have from magnesium, potassium, manganese, several diseases. But consider our acid soil, the most important for us is really potassium. Because you give a look, this side is considered the lower third of the plant, the middle third of the plant, and the upper side of the plant of soybean. This in the normal conditions with the indicated potassium amount for the soybean. But if you use less or you don't add potassium, you can have a so huge difference inside the plant about considering the size of the seeds. Look at this. You have quite the half of the size of your soybean seeds just because you didn't give enough potassium to the plant that they can produce a good quality of yield, of size of seed. So this for us in Brazil is the most important reality. We cannot forget for sure all the other nutrients, but this one is the most important. Is why can be explained by these numbers. So why we're so dependent of fertilizers? Brazil import 95%. This number is not just for soybean, it's for all crops. So we import 95% of the potassium that are used in the country, 55% of phosphate, and 80% of nitrogen. If we didn't have developed the soil well system using nitrogen fixation for soybean, this number should be in really more high than 80%. So you see, 44% of all these importations are used in soybean, 70% in corn, sugarcane, and other crops. But we had also a huge difference from the south to the north when we considered our climate conditions. We have in the south what you can consider a subtropical climate that have a range from 1,200 to 2,100 millimeters each year, that it's well distributed all around the year. We don't have like you have here 6 months of completely dry periods. So we have in this region winter with low temperature and really frequent frosts. Where I come from, here in Londrina, in the past we could have winters from 0 up to 12 degrees. Now, because of the climatic change, we are having winter from 15 to 28. But even extremely south, in this state, we can have winters with minus 20. So, and even snow. Even if we're a tropical country, we can really have snow in Brazil. So, another region, there is this, we say that climatic transitions from the center of Brazil. We have from 1,200 to 1,800 millimeters, more concentrated in the spring and the summer. It didn't mean that we don't have rain in the autumn and in the winter, but we have higher temperature winters, we quite never have a frost, and it's really when you have in this area that come from the south up to Amazon side, we have the Arctic cold, we can have a few days of winter. And the most important, our tropical climate, that is the most huge area of soybean production, that we have from 1,200 to 2,500 millimeters a year, really a summer with a lot of rain, a dry winter, totally different from you. We can still have some rain in the winter, but it's much more dry. But in this area, absolutely no risk of frost. And exactly in this area that we can sometimes make up 3 harvests in the same area in the same year. And now the discussion. Where exactly we can manage the soybean yield production. So we have normally our potential production. So GDM, EMBRAPA, it doesn't matter which company can say you, okay, you can produce 5,000 kilos by hectare with this variety. Perfect. How I can reach them? The most important, it doesn't matter the cultivar, the seeds. The most important for sure in soybean is water deficit. If you don't have water, it doesn't matter if you have the best material. Then, fertility. You need to manage the fertility of your crop, of your area, of your soil, to be able to produce exactly the high potential production you have. And then you have all the other ones. You have the pest and disease, the weeds, plantability, which seed you can use, and for sure, the inappropriate cultivar. If you have an inappropriate cultivar, it doesn't matter if you have a high potential, but you're using a wrong material in the wrong area. But water and especially soil fertility that is completely linked to the physics and biology of the soil, is really important to reach the high potential of soybean production. So one thing that also we have been discussing these last 2 days is maybe one of the most important things that that should be done here in South Africa is this agriculture zoning for climate risk. What means? We took quite 20 years to construct all these tools. It means that we had mapped all these orange areas that we can use for agriculture and know exactly which crop, which period, in which season, how we can manage this crop. And this is used as insurance also when the farmer go to the bank and they want to take money to help him to buy a machine or to start his production. The bank in Brazil take this in account. If you say that you start the production of soybean here, let's say, here is an area that's not recommended for soybean. So the bank will not borrow you any money because it's too risky for them to make insurance about your production. So this one is really important, not just for bank, but specific for the farmers to know exactly what I can produce, where I can produce, and when I can produce all around the year, especially considering that you have this quite 6 months dry period here in South Africa. It's important to know up to when in the year I can start the soybean or other crops production to be able to don't have any loss in the end of in the harvest periods. But when you're thinking about management of the soil, I think that the 2 most important parts of our soybean production is the no-tillage system and, for sure, the biological nitrogen fixation. We already saw with Nadine the importance of nitrogen fixation, but this is really a reality that all countries should be taking care about it. But for sure, these numbers of bioinputs, not just biological nitrogen fixation, but biofungicide, bioinsecticides, biofertilizers, solubilization. So we are increasing a lot. And Brazil also are taking care about what we call low carbon agriculture, especially because one of our markets, that is Europe, is always complaining that the agriculture in Brazil is not sustainable. So we are proving that we're really sustainable and we keep the carbonic gas inside the soil and we protect the environment also. So when you think about nitrogen fixation, we had really a huge start of using after 1995. So this is the number that we increase about, the no-tillage, the nitrogen fixation is later. So after 95, the no-tillage system in Brazil increased a lot, and you understand why in the 90s we have this difference when we shift several ways that we keep the soil conditions in Brazil. So actually, we have in the grain areas quite 70% of the whole country using no-tillage system. And the key principles of no-tillage system is exactly the soil disturbance only in the seeding row. Before, you see some pictures, it was common in Brazil to use hard disk pillows. We revolve the soil, we completely destroy the soil. It was in the past, so we completely shift this. The soil surface cover, we burn the soil up to the 90s in Brazil, exactly to clean all the surface. The crop rotations, in our case, we consider the crop succession because we will always have in our 47.5 million hectares soybean in the summer, and we just make a succession or a rotation as a second or as a third crop in the same area. That, as I told you, could be corn or wheat or cotton or even grass for feed animals. It depends on the regions. And for sure, we don't make tillage just 1 year and then we move on. This is something that is really a long-term benefit. We should keep doing all around the time. So this was like we managed the soil in Brazil up to the 90s. So small disc pillows, big disking, really revolving and destroying all the structure of the soil in Brazil. Now it's like we do it now with the no-tillage system. Covered soil, specific machines that just go in the lines and put the seeds exactly in the 5-10 centimeters that we need to put the seeds from the soybean. Several of these machines also are prepared to use the bio-inputs. Instead of mix the nitrogen fixation bacteria together with the seeds, we can put in some bags here and they apply on the row as a turfus or liquids, more turfus products that we apply inside the row together with the seeds to increase even more the absorption of this bacteria, the Bradyrhizobium, by soybean roots and even increase our productivity. So I remember when I was a child, this is really common. When you travel around the country, it depends on the period. Sometimes we could not pass in some roads because it was completely burning from one side to the other side. So because for the farmers, as clean as the soil is possible, easier for them to manage and to sow the soil. But now it's completely different. As much as you can cover, more you can protect the soil, not just thinking about the microorganisms, but especially the water. You keep the water, you keep the humidity of the soil here, because in some regions in Brazil, you can compare a covered soil and an uncovered soil. You can have in the summer up to 50 degrees in the soil in some areas in Brazil. So it's why we really are improving the system, and this is the best way that we can manage the soil in the soybean in the country. Another thing that you have with these pillows when you're revolving the soil is that we have a lot of soil losses by erosion. So you think that you can lose 20 metric tons by hectare by year without protection and really taking care about the soil. So independent of the region, what we have is this contour farming that with this we reduce the erosion in up to 95%. Just making these contours, depending on the inclination, all the soil, we need to do it exactly to protect about erosion. And also, one thing that's extremely important for the tropical soils of the winter crops is that sometimes we have this structure of soil, really big slices, big rocks. So for soybean, it's not being really recommended to start the production here. So what we normally do is we use, this is a grass, Brachyara residensis, that come from Africa continent, and we live for quite 3-4 months, exactly after the second harvest and before start to sow the soybean, exactly to improve the soil quality and the structure of the soil. So in some areas, we can have up to 2.5 meters of the structure of soil exactly that can manage for agriculture. And some areas we can do it. Just as in the Cerrado region in Mato Grosso, you can harvest the soybean and start to sow the corn. This is what we call the intensification of land use. But we can just do this scenario of land intensification use if we correctly manage how we look and how we keep the conservation and the structural fertility of our soil. So when you compare the south and southern of Brazil with Cerrado's region, that is quite the orange part that I show you, that is the subtropical raining periods. From the winter, look that all areas we have soybean from October to part of February. So the difference is, in Cerrado, we can have as a second crop maize, and then in this fallow period we have brachiaria, the grass, or it depends on the use of the area. If they manage with cattle, for example, after soybean, they come with long period of grasses production, with brachiaria production to feed animals, because it's more the period that it's dry for Cerrado's region. So instead that here it's more rain and well distributed, here in this area from March to June, July is more dry. So it's the reason that we sometimes, instead to do maize, the farmers prefer to come with grasses to feed animals. And some areas, like I told you, we are doing this integration, so brachiaria, forest, cattle, but 80% is much more livestock, and forest integration is easier to handle, but with the three of them, it's just in 3.5 million hectares, but it's increasing every year. About the soil inoculations, give a look. So after the beginning of 2000, also we increased the amount of inoculum. So actually, we are using more than 106 million doses in soybean to increase the productivity. We saw from that in the productions of the nodules of the soybean, this is look like a good and healthy Bradyrhizobium soybean nodule. So this one also was extremely important for Brazil to reduce their dependence of nitrogen. And when we give a look in the adoption rates all around the country, we can see that around 85% of all producers use nitrogen fixation every year. So the same region that I told you that in the morning that was saving seeds because their grandparents, great-grandparents also was doing like this. There is the same culture problem that we are showing, that using in this area, nitrogen fixation could improve, but sometimes they refuse to start or to try a new technology. Even nitrogen fixation is not really new. But one thing that we're starting also in Brazil the last 3 or 4 years is not just inoculation with Bradyrhizobium, but the co-inoculation with Bradyrhizobium, and another one, there is Azospirillum. This is already increasing in Brazil, and it's quite 1/3 of the country is also using this co-inoculation. But what is the advantage? So when I give a look in the roots of soybean, just with Bradyrhizobium, we can see the main roots and the secondary roots. When we co-inoculate with Azospirillum, we can improve the number and the size of the secondary roots in soybean. It means that they can fix more nodules to nitrogen fixation, but they can increase also the absorption of water and nutrients from the soil. So this is the reason that it's increasing in Brazil, this co-inoculation process, not just Bradyrhizobium, but using both of them. For sure, this Azospirillum is from Brazil, but The bradyrhizobin itself was not. So we need to adapt and to test and see exactly which one should be the best from each country and each region. Well, you all know how the bradyrhizobin works. So they take the nitrogen from the air, they fix here, and they give it. So what does spirulina do? It's improving the health of the amount and size of the roots, and also giving more water to the plant, increasing also the size and the weight of the soybean plant. Well, I didn't show you about how much the nitrogen fixation can save in CO2 equivalent in the production of nitrogen. Here, just to complement the information, it's a publication from a few years ago. With what we use in soybean of a nitrogen fixation, we could save every year around $15 billion that we don't need to use with nitrogen in soybean crop. And these numbers represent around 183 million tons of CO2 that we didn't deliver to the atmosphere, that we keep it on the soil. So this is the huge difference that using nitrogen fixation can bring to the plant, can bring to the environment, and also to the soybean production. It's not just a question of economic, but also it's environmental protection. But it's not, like I told you, it's not everything in the soybeans perfect. We have just bacteria, viruses, fungi, nematodes, caterpillars, stink bugs, whitefly, weeds. We need to handle all of them. Some of them is easy, some of them is not. So when you think about the cycle of soybean, we can have anthracnose, rhizoctone, sclerotinia, fusarium, phytium, just in the dumping of period. We can have also a little bit more diseases all around the cycle of the soybean. So you can have several diseases depending on the stage of the soybean. But for sure, we also have the nematodes all around the year. The difference is, in the last 20 years, we could handle with genetic breeding how we can survive or work together with nematodes on soil. The cost of nematicide is extremely high, not just for soybean, but for all crops. It's for the reason that the breeding program is as important as we have for genetic resistance for the most part of these diseases, and also from nematodes. Let's see a little bit about each one that I showed you. This was before the three main bacteria diseases that we have in soybean. So bacterial blight, bacterial pusto, and wildfire. Actually, really, the damage that we have with this bacterial disease is really limited in Brazil. These two, the pusto, so Xanthomonas and Pseudomonas, these two, we have genetic resistance. So like I showed you a little bit early, all EMBRAPA cultivars come with resistance to these two bacteria. We have also some viruses that was really important in the 80s, in the 90s in Brazil. Actually, we can see some viruses, especially TSV and motovirus, cowpea motovirus, but it's not really important anymore. We can handle. So if you have a part of the production with virus, we just took out the plants and replant, so we can manage this without any big financial problems or lack of production for the farmers. part of the fungi we can handle with genetic resistance. So Frugi, so Cercospora, Diaport, so Phytophthora, brown stem roots, all of them we can manage with genetic resistance in soybean. So this helps a lot to don't use, or even if they appear, you can easily manage with some fungicides. But the most part of our cultivars are resistant to these fungi. But this is some of the problems. The problems, the diseases that we cannot handle by genetic resistance, but we can try to handle with fungicides. These 4 target spot, brown spot, anthracnose, and phomopsis, is easily controlled by fungicides. So even if it's not big in Brazil, in big areas, the farmers can handle it. But these 4, the powder mildew, Cercospora leaf blight, the white mold that is the most important for you, that I just learned on Monday that it was important here, and the soybean rust that by far is the most important for us in Brazil. These 4 we try to handle every year with fungicides and also with best agricultural practice. So let's see a little bit of these 4. The first one, so the powder mildew, they can cause premature defoliation. They normally appear in cool temperature. It means that it's more important in south of Brazil. And they can give losses from 10 to 50%. But we can control with some resistant varieties and applying fungicides as benzimidazoles and triazoles during the phases R3 to R5. So this we can handle a little bit. The next one is Cercospora leaf blight. So they can also bring premature defoliation. The yield losses can go up to 20%, but we also can handle with resistant varieties, clean seeds. So this is one of the importance of buying certified seeds. And I don't work for private companies. I work in the public company in Brazil that make research. So we see every year how clean seeds is important for the farmers. The crop rotation, seed treatment, and also foliar fungicides in the same period, R3 to R5, and this is the mainly fungicides that we can use for this disease. And now, what is most important for you, the sclerotinia, so the white mold. And when I told on Monday and to Erhard, and we were talking about it's not really important for us. It's not that it's not important, it's because we just have around 3 to 4 million hectares. If we consider that we have an area of 47 million hectares. So it's not really a huge problem, and especially this disease become important just in areas there is over 700 meters. So we don't have a lot of areas of soybean productions in Brazil that is much more higher than 700. So we're quite limited with the sclerotinia problems in Brazil, and we can handle with some things like crop rotation, certified seeds, widening the row spacing, and this may be one of the biggest difference. We sow soybean in Brazil with 40 centimeters row. You do it here around 70, 75. So maybe the wide row for you should be tested a little bit more if they can or they cannot interfere in this case of sclerotinia. Physical barriers can also have a huge importance, but also the use of fungicides apply as protectant before the infection, especially during the bloom period. So normally you make 3 applications each 10 days of interval of each applications using prosimidone and fluazinam, this is from Brazil, that works to handle a little bit better with the sclerotinia. And for sure, for us, is why I have a little bit more slides from the Asian rust. I thought it was important also here. So this can give us losses up to 90%. So it's why we take much more care about rust than all other diseases in Brazil. And this is one thing that we try to handle with genetic resistance, early cultivation material, and one thing is important, it's the monitoring of disease. But one thing that we started in Brazil quite 20 years ago that all farmers respect is this soybean-free period. It means that from June to September, it's forbidden to have any type of soybean on the field. So the farmers respect because they know if they have soybean on the field, it can be a really good point of inoculant to produce rust. So after we start to do this free period, all farmers look at the benefits and they start to respect, and they do it every single year. And to finish, this is what we have to see in the country how we are having the rust. So all farmers have access to this app, and once the first time on the season it's appear on the crop, on the soybean, the first point of rust, they make a point and they inform. In this period, all farmers in the region give a look that they have rust in the area, and in this case, they start to prevent application of fungicides to reduce the risk of soybean. So instead to apply all around the year to control the rust, the farmers normally start just after appear the first spot, and then they can handle it better, and the reduction of fungicide application in Brazil really reduced quite 40%. And this was how it was before in the beginnings when the rust arrived in Brazil. We have products that could control 90%. Actually, no product, so this is the main one, can control more than 50%. What means that actually what we're using for rust control is really a mix of protective products, a multi-site like mancozeb and chlorotoluenyl, with other fungicides to reduce or to try to control exactly the fungicides. I can give you this presentation also. You can have this, you can download this soybean disease identification guide that is free, that EMBRAPA developed also. So you can see all the diseases that we have and try to identification on the field. And for sure, we also have problems with stink bugs, caterpillars, but these we could handle with biological control. And also some techniques that we can measure on the field the numbers of caterpillar and stink bugs before it starts to apply insecticides. And to finish our problems is the weeds. So we have several weeds that appear from soybean in the last 20 years. Some of them, it was really important in the beginning, 22 years ago, and after all the glyphosate application, okay, it was no more problem. And then what happens, these 5 weeds here now is glyphosate resistance. So we really good select the best weeds in Brazil because they're all resistant to glyphosate. So the sourgrass, we have around 18 million hectares that we can find sourgrass. The horseweed, 70 million. And these two, Amaranthus, that you already have here, and Elusina, this goosegrass, is increasing for now 4 and 8 million hectares, but all this area we can find more, and for sure, we have much more weeds that we can control, but all of them are still suitable to glyphosate and other herbicides. And the last one, I promise, I finished, Peter. You see to the integrated diseases management in soybean, the chemical control is maybe the last that the farmers should use after to plant the soybean. So first, they need to do all these measurements of the crop. So resistant cultivars, no-till system, balanced nutrition, soil management, crop rotation, plant population, seed treatments, seed quality. So then, if you still need to apply to control with fungicide, herbicide, or insecticide, then you use it. But with this, you reduce the cost for the farmers, you improve the safety and the environment and also the water. So thank you very much.
Right, thank you very much, Leandro. There's a wealth of insight, and it's